Hello and welcome to week 4. We're going to take a look at object-oriented programming. So, if you remember from last week, we talked about functions, right? The real reason for functions and what we're trying to do is encapsulate our code in a really easy to use format so we can write it once and use it a bunch of times, right? So if we're in some sort of business and we often import this set of data or do a calculation on that set of data, we can just use that function over and over. We write it, kind of the best of our abilities once, and then we know we have it working with the right inputs and outputs. So it gives us convenient reusability, which is really a big goal in coding, right? In this class, we're coding from scratch and we're coding very small things. But if we want to code big things, then we have to start, figuring out what the building blocks of those big things are. And so functions are a good way to do that. We might share a function with somebody else in our organization. Say, hey, I got a function that does this. It's really useful. And somebody else says, oh, I need that. And they can just use it and maybe not even know all the code that's inside it. So the class that we're going to learn today is sort of a fancier version of the function. So classes come from object-oriented programming, where we create objects. An object is something that has storage like a variable and can do things like a function. So if you think of a variable and a function combined together, that's kind of what a class is. Historically, most programming languages did one or the other. They used sort of the functional programming syntax or object-oriented syntax. The people that wrote Python were trying to make it like in everybody's language. It kind of does everything. And so you can program it like you can use functions or classes. It's up to you. But many times the classes gives you a way of better encapsulating a lot of code because they're grouping a bunch of variables and functions together that kind of work together in a similar way. Okay. You saw we've had two different kinds of syntax for calling our functions, right? Sometimes we say the function name, open parentheses, and give it the arguments and we get an answer back. Sometimes we start with the variable name, a dot, and the function name. When we use a variable name, a dot, and function name, that's technically a method. Method is just word for a function in a class. So you don't really worry about it. I might use them interchangeably myself. And so the the string data type in Python is technically an object, and because it has those dot functions, which are methods. And a method is a function that can operate on that variable. So let's see how we put those together. First, I'll start with the example from the book. They have a little simpler example, then I'll do more of an extended example of my own. So this is from chapter 14, and we define a class. So if you remember when we defined a function, we use def, and that makes a function. When we define a class, we use the word class. The name of my class is example. Again, the naming convention is to start classes with capital letters. It helps us kind of distinguish them in the code, so it makes it easier to read. And example colon starts a block of code, and then you'll see def again, right? Def is what we use to define a function. Here we say we're defining a method within the class function. If you call it a function, it doesn't bother me, but so these DEFs are really the DEFs here that define the methods within the class are the same as what we've learned in functions, with the exception that they're in the block here after the keyword class. Okay, same thing, indentation. So the thing about a class, it's a variable, right? So a variable like, we used my name or X or whatever in the past. It doesn't exist until you use it for the first time, right? If you do print X and the X was never defined, then it doesn't exist and the print statement will fail. right? So you have to say x equals 5, and then you can say print x, right? So the x has to exist. So the same with a class. So a class is a definition of an object or a variable, and that variable doesn't exist until we make it. The function that creates the variable is called init. And I'll show you how that works in a second here. So this first function is a little bit different. It starts with 2 underscores and ends with 2 underscores. Okay. So the init function is the function that initializes the variable. The inputs to that function here are similar to what we've seen to inputs to a function. You'd have to give it an x and a y, but the self thing is special. Self just means the variable can access itself. It almost seems like that's redundant and you wouldn't need it, but you do. So that is the variable itself that you're about to create. And so in a sense, it only has 2 real arguments to the function, right? The x and y are new information. They're arguments when we call the init function. The self we include here in the definition of the function just to say we can access ourselves. Okay. So x and y are the input arguments to a function, kind of like a regular function. When we do something like self, that means the new object we're about to create, dot a, that means the a variable. That's a variable, but it's a variable in this new object. And we're going to say the a variable is equal to what the calling function put in the x. And the b variable is equal to what the calling function called in the y. So to recap, we have an object of type example. If you create, think of that as a data type. So the data type is example. A variable, I'm saying the words wrong, right? On purpose. I'm using our old language from functions. But a variable of type example would have 2 variables within it, A and B. And when we create the variable in the first place, we must give it those 2 values for it to create the variable. Line 16 shows us how to create it. So E is a variable, right? The equals is assignment, just like we learned before. The data type of E is example. And to get an object of data type E, you must give it 2 numbers. That's because of the way the init function was set up. So you give it 8, the 8 gets copied to the X, the 6 gets copied to the Y, right? But that, making them in X and Y is just an input to the function, so they haven't been used yet. Inside the init function, we assign those to A and B. So E now has 2 variables to it, A and B, and they're assigned 8 and 6. Now E exists, and you could print out E, or the other functions here are all the methods that operate on E after it's created, right? So the init was unique. We run it once just to make the object. And then other functions are things that function can do. So E.add returns A plus B. And again, you'll notice the add, like some of our, right, we've used the methods before with the strings. There's no input arguments to add because it's just operating on its internal variables A and B that are already part of that object. So the return value is A plus B. Right, you'll notice there's no arguments in the call to the function, even though the definition still has the self in it to say the function can address itself. And then add x. That's a function. That's a method that can add a plus b plus a third number. So if that x here is indicating we need an input, so e dot add x. The 3 gets copied to the x. The a, the b, and the x get added, and that's the return value that gets substituted down here to do that print. And I can run that, and a little delay, and I get 14 and 17. Okay, that's the idea. And so we use this when we think of something that has data and can do a bunch of different things. We kind of encapsulate the variable that we're saving some information with the things it can do. It knows how to add and knows how to add another number to itself in this example. So that's from the book. Let's go on to a little bit longer example here. So here we can think of a hotel or a customer as a class or an object, right? So if you think of a customer is someone that has multiple pieces of information, right? So they might have their name and their phone number and stuff like that. So all of those could be part of the same object. Okay. And then there may be, certain things we can do for a customer. We can ask them how they're doing. We can call them. So there's a bunch of functions you could do with a customer, and we could put those in there. Okay. So the idea that the variable has multiple pieces to it, you can think of that as a little bit like the dictionary we used in the last class, but we can also apply functions to it. So I'm going to define two classes here, a hotel and a customer. And so I'm kind of making a hotel information system, and both of those with two objects in it. And I'm just going to use some random numbers just for the fun of it here. So I'm importing the random function, but it's not really that important to this example. So let me scroll down to class hotel guest, right? Class is the keyword. We're going to make a new class. Hotel guest starts in, it uses the uppercase or the camel case naming convention. So that helps us keep our class names separate and they don't overlap. Python is case sensitive in its variable names. So if you always do classes that way, you kind of know you're not using a variable name or something like that, because we use the snake case for the variables. So a class to represent a hotel. So this, I mentioned it before, the doc string is usually used to document both functions and classes. Starts with three quotes. Basically, instead of being a comment, which you could use, just a convention to use strings, it's a string, but there's no assignment of the string. So it's like a string in the middle of nowhere, but a string in the middle of nowhere is just going to be ignored by Python. It's not doing anything with it. And but it's used for documentation, and we usually have the first line has a period, there's a space, and then detail lines follow with those. So hotel guest, it has attributes. So this is my documentation, but if I scroll down, you can see where the attributes come in. If you want the attributes to have values, then the init function has to set them to values. So we start with an init function, and to make a new customer, you have to provide 4 pieces of information: first name, last name, phone number, vegetarian. Note, right? I'm not using any default values or anything here. Just positional arguments like we learned last week. You could use the default values in here as well, like we did in functions. Okay, and then I got a doc string here defining the init function. And you can see self dot first name equals first name. So don't mix that up. The first name on the left and the first name on the right are completely different variables, right? As a function, we have to give it an argument. That argument is placed in the variable first name, and that's a local variable to the function. The self dot first name means we're defining a variable that'll be persistent within that object. And so that's why it's kind of funny here. I put in this third one just to show you that there's not a one-to-one correspondence between the objects in your variable, in your object, and the objects that are inputs to the function. So I could have this defines full name as a variable within the object, and it is defined by concatenating first name and last name. So there's 5 persistent variables within the object. So that would be how I would make a new customer. Let's go. I'm going to skip down to where I actually make a customer so you can see that. Let me just See line 106, new guest equals hotel guest, Bob Smith, phone number false, right? So there's the 4 arguments. And now this variable, so I have a variable, new guest, which is actually the data type of new guest 1 is hotel guest. And it has 4 attributes within it. And it has the ability to call any of its methods. So if I go back here, what methods can I call? Well, after the init is done, right? Mood, right? So mood returns the mood of the guest. That's where I threw in the random variable just for fun. So it says if the guest can be doing well or not doing great, and it's just randomly returned. So a guest has a method mood where you can, which returns a string describing the mood of the guest. Just kind of random. The if is done with a random variable here just for fun, really. So that's what a guest is. A guest is something that has 5 variables within it and can tell you its mood. Those are the things it can do. My next class is hotel. A hotel is an object, again, init. How do we make the object? All you have to do is give it a name and it becomes a hotel object. However, look at all the variables within it. So when you create a new hotel, you must give it a name. That's why this is here. And when it's created, the hotel name variable within the object becomes the hotel name you gave it. But it also has 3 other variables: guests, former guests, and menu items. And they are set to, and I don't know if we've seen exactly this before, to open bracket, close bracket. Well, open bracket means we're defining a list. And if we put nothing in the list, it is in fact of data type list, but there are no items in the list. The reason we're doing that is because the guests of this hotel initially there are no guests, but we do have a placeholder for a list, and we can eventually build a list of guests. And building lists of guests are kind of like we did last time. Think of a list of guests. Last time we did a list of dictionaries. Our list of guests here will be a list of guests of type back here, right? They're going to be this data type here, hotel guest. So hotel guest is an object, and guest is a list, can be a list of anything, we don't really know. But in this example, it's going to be a list of hotel guest objects, which kind of parallels what we did last time with a list of dictionaries. Because remember, a dictionary sort of had different pieces of information in it, kind of like the object does. So former guests and menu items are the same concept. Check-in. When a hotel guest comes to the hotel and checks in, the hotel object has the ability to check in a new guest. So new guest is the argument. And what it does is self dot, right? So into the self is the hotel. Guests is this empty list we created. Append means take the new guest and append it to the guest list, right? So the dots here, right? Self means the hotel object. Dot guest means the guest variable within the hotel object that's here. And append, because guest, the data type of guests is list, right? So append is a built-in method of list objects. So we can append things to it. And what we're going to append is the new guest that was given in the argument. And it doesn't explicitly say it here, but new guest should be of data type hotel guest. When we check out of the hotel, right? We give it the guest name that's checking out. Remove is done from the guest list, and append is done to the former guest list. So we check them out by just taking them off the list of guests, right? Kind of oversimplified, idea of checking somebody out. But they are appended to the former guest list so that, maybe we can send them some advertising or something. We don't want to lose the data about the guest when they check out. So that's what we're doing there. And then some other things we can do. We can print out the guests. We can print out the former guests. We can count the current number of guests, see if we're overbooked. Okay, and let me just show you how all that works. Right, so here, before I show you that last example, but here, line 105, my hotel equals a hotel, Palace Hotel. That means I've created a hotel object. New guest one is I've created an object. I print out new guest one and their mood in line 107. So we'll go down here to the output, right? Doing pretty well is the mood. Right? And then I check that guest in, right? So new guest one, I created new guest one, and then I checked new guest one into my hotel. So my hotel has to exist already. So my hotel is there. And then the dot check-in means I called the check-in method. And I handed the check-in method the new guest one object as the argument to that function. And then, like we saw before, that appends it to a list of guests. New guest two, I made a second guest. I checked the second guest in. And then 111. This is where, I keep saying you can teach yourself Python. Well, you want to print out things that you've put in so that you see they happen the way you want it, right? I've checked in two guests of the hotel. So now I'm going to call the print guest method of the hotel so I can make sure things are happening, right? So some of your methods, you might throw a method in there that's not even needed in your final application, just so you can understand that the data is going kind of where you want. And so that's why I print that out. And so here, current guest list, Bob Smith, Sam Spade. Therefore, the object was able to print out its guest list. So I'm just proving to myself I use that list function well. Okay. Yeah. So some other things I do: test check-in, check-out procedure, right? What does that mean? Well, I got another guest. I created a hotel guest. I check that guest in. I print the guest list, and I print the number of guests in the hotel, and I print the former guests. And now I take that guest. I just checked in this guest. Now I check them out, right? If I check them out, they should be in the former guest list and not in the current guest list. And so I print that out. And so that's what you see here, right? Begin, check in, check out, test. I call it a test just for myself, right? I make the current guest list and the former guest list. And then I reprint the current guest list and see that that person is checked out. All right. So your class could get fairly complicated. Make sure you're doing things to test that it's working right, such as this. And you can see it really. So the good thing is anything you could do with the hotel data type could be included as a method, maybe many more than this. And if you got that working well, but maybe that's a data set. What are the things you normally do in your analysis of a data set or something like that? Um, and so all of those things can kind of be encapsulated. Once you get that written well, it can be reused. And let me go on to one last thing, and that is inheritance in classes. So in line 96, we have a new class, the can't leave hotel, and what's in parentheses is hotel, right? This is a little bit twist on the syntax. I'm creating a new class, can't leave hotel, but with hotel, another class name in parentheses. That means I want to inherit everything from a hotel. So the can't leave hotel has everything that the hotel had, but if I redefine a method here, and I use the same name as the method in the hotel class, it will replace that, right? So can't leave hotel has init and checkout. What did hotel have? Hotel had init check in. Well, check in init is going to get overridden, right? Because I've done that before. Check in will not get overwritten. Checkout will get overwritten. Print and the print guess will remain the same. So here we give it a hotel name, and this has menu items on it. But you're not allowed to check out of this hotel. If you attempt to do the checkout method, it will say you can never leave and won't actually check you out. So can't leave hotel is a class that inherits everything at first in hotel, and then anything repeated, any method repeated, will override the method related. So the purpose of this inheritance is if you've created something you kind of that you like, it works really well, but you need a new version of it with like one thing change, you can inherit it and override a method. Of course, you can inherit something and override a method, and then inherit that class and override it. A long string of inheritance actually gets confusing, so you don't want to kind of go that crazy with inheritance. Just in maybe one level, one systematic way. But if you did a whole bunch of that, it would kind of get confusing. Okay, so give that a try. Start something simple to teach yourself, right? Start something simple, but also do something that has set it up with some data, maybe a method that changes some of that data, right? You can use self.a and save a value to it, and do something that outputs some data, right? Because you want to create the object, put some data in it, manipulate that data, and you can show to yourself that it worked. All right, thanks. Appreciate that, and see you next time.